So we've seen in stoichiometry that we can get information about any chemical in a balanced chemical reaction as long as we have information about one chemical. And we get that relationship from the mole-to-mole ratio from the balanced equation, from the stoichiometric coefficients. Now, the unfortunate part about this is in the lab, we can't count number of moles. All we can do is get the mass of chemicals by using a balance. However, we can relate the mole and mass of any chemical by its molar mass. And we have to calculate the molar mass for each chemical because molar mass depends on composition. But as long as we have a chemical formula and a periodic table, we can easily calculate the molar mass of any chemical. So the molar masses of chemicals in the balanced chemical equation allow us to convert between any two chemicals in a balanced chemical equation. And here's a little graphic. If we have the mass of one chemical from a balanced chemical equation, we can get to its moles by dividing by its molar mass. Then we can get from chemical A to chemical B, a different chemical, based on the stoichiometric coefficients. And then we can get to the mass of B by multiplying the moles of this new chemical by its molar mass. So in both cases, we need the molar mass of two different chemicals to get between the moles of the chemicals. Now we need to get in moles because to get from one chemical to another, the stoichiometric coefficients are always in moles. So we have to get to moles to get from one chemical to another. So let's look at this example question. How many grams of glucose can be synthesized from 58.5 grams of carbon dioxide in photosynthesis? So here is our photosynthesis balanced equation. For 6 moles of carbon dioxide, 6 moles of water are required to react with it. And then 1 mole of glucose is synthesized as well as 6 moles of oxygen. So we're given information about mass, and what we have is a balanced chemical equation, and our stoichiometric coefficients are in moles. So what we're going to have to do is we're going to have to get from grams of carbon dioxide to moles of carbon dioxide. Once we have moles of carbon dioxide, we can get to moles of glucose based on our 6:1 ratio. Our answer will then be in moles, and to get back to grams of glucose, we've got to multiply by its molar mass. So in mass-to-mass stoichiometry, we always take our mass, get to moles, use our mole ratio to get to our desired chemical, and then take our desired chemical to mass by multiplying it by its molar mass. So here's the summary of what I just said. When we're looking at mass-to-mass stoichiometry, we get our mass of our given chemical to moles by using the molar mass. Then we get to our desired chemical by using our mole ratio, and we get this from our balanced equation. Finally, we'll get moles of desired chemical from this step right here, and we convert our moles to mass by using the molar mass. So mass to moles, and then moles to mass. These two steps require the calculation of the molar mass of the chemicals, and only this middle step involves the coefficients from the balanced equation. So let's take another look at our example. How many grams of glucose can be synthesized from 58.5 grams of carbon dioxide? And this is important. Assume there is more than enough water to react with all of the carbon dioxide. So here's our balanced equation. We want to write down what we're given and what we want to get. When we write down our given and what we want, we see that we have grams of carbon dioxide and we want grams of glucose. Anytime we're given information about one chemical and we want information about a different chemical in a balanced chemical equation, we need to use stoichiometry. And stoichiometry always uses a mole ratio from the balanced equation. Now, in this case, we're given grams, and we want grams. However, to use our mole ratio, we need all quantities to be in moles. So the first step is to convert our given to moles. And then we're going to have to take our moles of our desired chemical and multiply it by its molar mass. So since we have grams of both of these chemicals, we're going to need the molar mass of both. Let's go ahead and calculate the molar mass of both, so when we do our math, we're not going to get bogged down by having to stop and calculate the molar mass. So the molar mass of glucose, we have 6 carbons, 12 hydrogens, and 6 oxygens. If we look at our periodic table, a mole of carbon is 12.01 grams, mole of hydrogen 1.01 grams, and a mole of oxygen 16 grams. So when we multiply these values and add them, we get 180.2 grams per mole. This is the molar mass of glucose. The molar mass of carbon dioxide, there's 1 carbon and 2 oxygens. So 1 mole of carbon is 12.01 grams. 1 mole of oxygen is 16 grams. 2 times 16 plus 12.01 is 44.01 grams per mole. So here are the conversion factors that we calculated. We calculated the molar mass of carbon dioxide, 44.01 grams. We calculate the molar mass of glucose, 180.2. And we need those because we're going to have to go between grams and moles anytime we do stoichiometry if we're given grams. We're also going to need our conversion factor from the balanced chemical equation that tells us the relationship between glucose and carbon dioxide. Okay, so now we're going to do our railroad math. We take our given, we look at our wanted, and make sure we have 2 of each units. Grams of CO2, grams of CO2. Grams of glucose, grams of glucose. Moles of glucose, moles of glucose. Moles of CO2, moles of CO2. Okay, so I have 2 of every unit, and I'm ready to start. I always start out with my given, 58.5 grams of carbon dioxide. Grams of carbon dioxide must go down here, so 44.01 grams of carbon dioxide, and then 1 mole of carbon dioxide at the top. My grams of carbon dioxide cancel out. I have moles of carbon dioxide, so I must have moles of carbon dioxide down here. Here's my conversion factor. 6 moles of carbon dioxide, 1 mole. Whoops, I didn't write my formula right there. C6H12O6. My moles of carbon dioxide cancel out. And then my last step is to convert between moles and grams. Whoops. Okay, so by using my railroad math, I see which factors cancel out, where to place each conversion factor, and my final units are grams of glucose, which is what I want. The key to solving this problem is writing out all your conversion factors. These are calculated, and to get from moles of one chemical to another, this comes from our balanced chemical equation. Then we do our math, and my calculator tells me 39.88173, etc. Let's look at how many sig figs I should have. My original value has 3. It's going to be my last allowable sig fig. I look to the right. That's greater than 5, so 39.9 grams of glucose is my final answer in correct sig figs. So again, to review, in mass-to-mass stoichiometry, we take the mass of our given chemical, change it to moles using its molar mass. Use the mole ratio to get from the given chemical to the desired chemical. This comes from our balanced equation. And then convert the moles of the desired chemical back to mass using molar mass. Now if you write out all your conversion factors and do it by the railroad math, these steps take care of themselves.